Hey everyone, today we're going to be talking about nomenclature. Specifically, we will be naming alkanes, organic molecules that have only single bonds between carbons. We are also going to be going over some tiebreakers that can be helpful to deduce the name of the molecule. This is just some information about the tiebreakers that we will need to know. We don't have to worry about it making sense yet. We will just refer to this when we're going through the examples on the next page. Let's look at this first molecule. To begin the process, we want to find the longest chain of carbons that we can make. One way we can do it is 1, 2, 3, 4. A second way we can do it is 1, 2, 3, 4. Now that we have multiple options, the tiebreaker is that you select the main chain that has the most substituents or branches off of the main line. In this case, we have 1 on either way we choose, so we can pick either. We'll just pick the top one. Since this main chain has 4 carbons, this is a type of butane molecule. But is the prefix indicating 4 carbons, and ane is the suffix indicating that it's an alkane. Now we need to figure out how to number our main chain of carbons. We want to number it in a manner such that the first branch, if there are multiple, has the lowest number, because we can number it this way, as depicted, or we could be numbering it backwards, the opposite way. The first way we numbered it gave our branch on the second carbon. The second way we numbered it gave our branch on the third carbon. So we are going to choose the first way, because 2 versus 3, 2 is the lower number. Now we have a branch with 1 carbon that is hanging off this molecule. Every branch will have a YL ending as opposed to an ane suffix. Since it is 1 carbon, it has a meth prefix, METH, making this group a methyl group. So now we know we have a butane molecule with a methyl group hanging off the second carbon of the main chain. We're going to name this molecule 2-methyl butane. So essentially the order is the number of the carbon dash the name of the branch followed by the main chain. Let's repeat this process with the next molecule. In this molecule, the longest chain is 7 carbons. Now, there is another way to number it with 7 carbons, which is, however, the bottom one only has 2 branches coming off, while the first way we numbered it, or selected our main chain, had 3 branches coming off. So we are going to choose this top version. Now, since the longest chain is 7 carbons, this molecule is a heptane, where hept is the prefix indicating 7 carbons. Ane, again, because it's an alkane. Now, do we keep the numbering this way, or do we switch it around? Meaning, number it like this. If I switch it around, the first branch is on the 4th carbon as opposed to the 2nd carbon. So we are going to keep it the way we have it. Now we have 2 branches that are 1 carbon each, so they're both methyl groups. And we have a branch that is 2 carbons. This will also have the YL ending, and it has a ETH prefix for 2 carbons, so we call it an ethyl group. Now the 2 methyl groups are on carbons 2 and 4, and we have an ethyl group on carbon 3. First, I'm going to write out the name for this molecule, and then I will explain it. This molecule is 3-ethyl 2,4-dimethyl heptane. First, the di. The di, the reason we have it is because there are 2 methyl groups in the molecule. If we had 3, we would put tri before methyl, and if we had 4, we would put tetra before methyl. The next reason ethyl comes before the dimethyl is because we order the branches alphabetically, excluding the di, tri, or tetra prefixes. Ethyl comes before methyl alphabetically, so we put it in that order. Finally, for a molecule that has multiple of the same branch, you list the number of carbons they hang off of in order, separated by commas. So since the 2 methyl groups were on the 2 and 4 carbon, that's why we have 2, 4. Let's work on this molecule now. I see a 6-carbon chain. So I know that it is a hexane molecule. There is another way to make this chain. I will let you do that yourself and see that it has the same number of substituents or branches, so it doesn't make a difference if we choose this way or the other way. Now, this molecule has an ethyl branch because that branch has two carbons, and a methyl branch. Now, if we were to number it the other way, this main chain, we have the first branch on the 3rd carbon and the second branch on the 4th carbon, no matter which way we number it. So we need a tiebreaker for this. The tiebreaker is that the lowest number goes on the branch that comes first alphabetically. So we are going to pick this way of numbering the branch because the ethyl comes before methyl alphabetically. That's why the ethyl gets the lowest number. Since we have an ethyl on the 3rd carbon, a methyl on the 4th carbon, and we know that this is a hexane molecule, we will name this 3-ethyl 4-methyl hexane. There is no need for any of the di, tri, or tetra prefixes because there are not multiple of the same branch in this molecule. In the next molecule, there are again multiple ways to make the longest chain. One of them is, so we have a 6-carbon chain molecule here, at least for the main chain. However, there is another way to draw or count the longest chain. The first way only has 2 branches coming off the main chain. However, the second way has 3 branches coming off the main chain. Since the second way has more branches off of the main chain, we are going to choose the second way. This is why it's important to make sure you choose the right chain and not the first one you see. It's not always going to be given to you in a nice horizontal format like the molecules above. Now, for numbering, let's check if this is the correct way to number or if we need to reverse the order. In both ways, the first branch comes on the 2nd carbon. We need another tiebreaker, so we go to the next available branch and look for the numbering system that gives that branch the lowest number. So on this first molecule that we drew, the second branch comes on the 4th carbon, whereas on this molecule, the second one we drew, is on the 3rd carbon. So we are going to check or use the 2nd carbon molecule that we drew, the second numbering system. Now, we have 2 methyl groups hanging off the 2nd and 5th carbons. And we have an ethyl group hanging off the 3rd carbon. Ethyl comes before methyl because of alphabetical order, And we have a hexane molecule because our longest chain is 6 carbons. So we are going to name this 3-ethyl 2,5-dimethyl hexane. The di, once again, is because we have 2 methyl groups in the molecule. With this last molecule, let's find the longest chain, starting the process all over again. With my strategy in finding the longest chain, I tend to look for one end of the molecule and just go till I find the other end. With practice, you will start to kind of guess which parts of the molecule will give you the longest chain. So I'm going to start with 1, 2, 3, 4, 5, 6, 7, 8. Now I could diverge and go this way for the 7th and 8th carbons, but it doesn't make a difference as both ways will have 3 branches coming off. Just choose one way and stick with it. Now let's check if this is the correct way to number it or if we want to go reverse. Now, both ways, we get our first branch on the 3rd carbon. So we're going to look for the next closest branch. Numbering it the first way we had it, the second branch comes on the 4th carbon. However, if we were to number it the second way we did it, with the red numbers, it would be on the 5th branch. So we will be choosing the first way we numbered it because that gives us the lowest numbered carbon for the second branch. Now that we have that cleared out of the way, let's name our groups. We have an ethyl group, another ethyl group, and a methyl group. Since we have 2 ethyl groups on the 4 and 6 carbons, we will be using the di prefix with naming our ethyl group. Also, we have an 8-chain carbon. So overall, this is an octane molecule. Ethyl comes before methyl alphabetically, so let's go ahead and name our molecule. This will be 4,6 diethyl 3-methyl octane. Thank you so much for listening.